Hello, this video is to explain some of the chemistry of alcohols and aldehydes, and I'm going to use a past paper question from F324 Jan 2010, question 2 to help. So starting off, as is a very typical way, examiners give a chemical that you've probably never come across and some information that turns out to be interesting but essentially irrelevant in terms of the name, but very useful in telling you that there's both an aldehyde and an alcohol. So you're given the structural formula. The very first thing that I've done is I've drawn out a displayed formula, always much more helpful to see what's going on. So you can really see there is your aldehyde group and then there is the alcohol. So throughout the whole of the question there's going to be some redox reactions. So you know that there is going to be some reduction and there's going to be some oxidation. Remember that, we're going to come back to that later on. And we're going to get several different products. Well, that's because we've got two functional groups, and so they are going to look at different ways to oxidize or reduce as appropriate. So the very first thing, the biochemist reacted hydroxyethanol with Tollens reagent. Two things to know about Tollens reagent. The first is that it contains silver 1+, and it is an oxidizing agent, and the silver 1+ gets reduced, so plus an electron, to form silver. So what you observe, they want you to write a silver mirror. Often putting silver solid will get you the marks, but silver mirror is the thing they want. So the silver 1+ is reduced and it is an oxidizing agent. So the second thing you need to know is it tests for aldehydes. So it's testing for aldehydes, but we've got an aldehyde and it's an oxidizing agent. It's not going to do anything at all to the alcohol, it's only going to react at the aldehyde and it's going to oxidize it. So the way we could oxidize this is to turn it into carboxylic acid. Now, reading the question carefully before we go further, it wants the structural formula. Well, all of the things on the left won't change, so HOCH2, just like we had here. And what we're going to have is we're going to turn the aldehyde into carboxylic acid, so it will become Cu. Right, next bit down. The biochemist also reacted hydroxyethanol with acidified dichromate by heating under reflux. Write an equation for this oxidation. So hopefully you already know it's an oxidizing agent. Equation for this oxidation, there's a key bit here, it's under reflux. That means that a primary alcohol will go all the way to a carboxylic acid, but it will also take an aldehyde to a carboxylic acid, because that's essentially the first step in oxidizing from a primary alcohol all the way to a carboxylic acid. What this means is, looking at the molecule here, there is one hydrogen to carbon bond that can be oxidized on the carbon on the right, and there are two in the carbon on the left. So altogether you are going to do 3 oxidations. Refluxing acidified dichromate with an alcohol will give you a carboxylic acid, and refluxing an aldehyde with acidified dichromate will also give you a carboxylic acid. If it helps, draw it all out in displayed, and then you probably are going to get the marks if you do that, but you can hopefully then see that you could write this as HOOC COOH. Now, to oxidize the aldehyde, we essentially just insert an oxygen in the carbon-hydrogen bond. But when we're oxidizing the alcohol, we are removing 2 hydrogens, and it's an oxidizing environment, so your byproduct is H2O. In this whole thing would give you 2 marks. If you had only partially oxidized, then as long as it was balanced, you would have got 1 mark. So it's essentially 1 mark for getting these products and then 1 mark for balancing it with the 3 oxidizing agents. Okay, remember at the beginning we said redox is going to be reduction and oxidation. Turns out that that was actually getting towards part C. The biochemist then reduced the hydroxyethanol using aqueous NaBH4, so we know it's going to be reduced. Now, we'll come back to part 1, but if you didn't have any of the mechanism, you would hopefully be able to look up here and know that the only thing you could reduce would be the aldehyde. So, NaBH4 is a source of hydride ions. There's H-, and they are very reactive, and they're not something you would come across before. We are going to draw them in rather, and it has a lone pair of electrons and it's negatively charged, so you know that this is a nucleophile. It is going to be attracted to something that is positive or delta positive. I've drawn the molecule out already to save time for you watching the video, but whenever you get these organic questions about mechanisms, draw the molecule out and add your dipoles. So I've got my delta negative oxygens, I've got all my lone pairs in, I've got my delta positive hydrogen here, but that would, if it's reacting here, because H- would be attracted to the H+, this isn't a reduction, this is just it removing it, essentially being a base. So we hopefully remember and know that if you've got a nucleophile, carbonyl, carbons, the delta positive, is where the reaction is going to take place. So a curly arrow, which you're asked to show, is the movement of a pair of electrons. It always starts at the electron, so start it right at the lone pair. You possibly want to draw slightly less colour than mine, but hey. So I've managed to snake its way directly to the carbon. If you've got small writing, make your molecules bigger. Make it clear to the examiner that it starts at the lone pair and goes to the delta positive carbon atom. So that would get you your first mark from these 4. Now what happens is that this carbon would end up having 5 bonds, because this is like us forming a dative covalent bond. You then have a delta negative oxygen, and what happens? Draw an arrow from the bond to the oxygen, and it's pulling away that bond, so the 2 electrons that were in the bond from carbon to oxygen get pulled round to the O. That is your second mark. Mechanisms: everything that has not changed, put it right in where it was. No matter how much of a complicated molecule there is, everything else stays the same apart from the reactions at the functional groups that you know about. We now have formed a bond from the carbon to the hydrogen. We still have a single bond to oxygen, but it's now got 3 lone pairs and it is a negative charge. There's a third mark for this intermediate, and it is an intermediate because you've got an O-. Key, this was aqueous NaBH4, so what you will have is some water, and you've got here a lone pair from the oxygen. Carefully draw it to the hydrogen, and then the oxygen that was part of the water pulls the pair of electrons that were bonded to the hydrogen away. So the hydrogen always ends up being part of a bond, it's just the oxygens swap, they pass the hydrogen across, and that would get you the 4th mark. They don't actually ask you to show they don't give a mark for the final product there, which is kind of strange. I'm going to draw it in just because I think it would be helpful. Everything that hasn't changed for this step I'm going to do first, and that shows us that we've taken our aldehyde and we've turned it into an alcohol. So for the structural formula, earlier we saw it started off HOCH2, that's how it was written, and if you look here, well, it's the same, it's CH2OH. And that's your marks. Thank you.